Okay, this is continuation of spring constant and weight. All right, so a lovely, amazing physics student comes by and sits in Mrs. Nagel's ball chair. The ball has a spring constant of 2,400 Newton meters. The ball is compressed 30 centimeters. Got to convert that into meters. 0.30 meters, 3/10 of a meter. Okay, so that's like it's pretty decent. All right, what is the spring force? So I'm looking for Fs. What's that? And then what else it says? What's the weight of the student in Newton? Well, that's force of gravity. Now, what's the difference between the mass and weight? Weight is the feeling of heaviness. Mass is the stuff. Okay, and that's a G. All right, let's do the force of the spring constant. What's the force of the spring? Well, you got to take your reference table. Fs, force on a spring. K, our spring constant, which is given, and X. X is the elongation or stretch. So elongation or the stretch, or the squishing of the spring. So that's the change. That's the part that changes. All right. So I'm just going to put Kx, put that down. Force of the spring, 2,400 Newton meters times 0.3 meters. Multiply the meters together. Meters cancel out. You're left with the Newton. And I forgot to calculator. Darn it. Hitting pause. Okay, I plug that in. Hit equals. And so the force of the spring is 720 newtons. Now, how do I find the weight? Well, the kid's sitting on it. Sitting on the ball chair, whatever. Here's the ball chair, right? It's compressed. It's compressed 0.3 meters, 30 centimeters. And what else do I know? Well, if I draw my free body diagram, I have force of gravity going down, force of spring going up, and they're balanced. So I can write force net equals ma. They're balanced, so there's no acceleration. So force net equals 0. The force of the spring plus the force of gravity in the opposite direction will equal 0. So that makes these equal and opposite forces. Woohoo! Now I can just say, well, what do I know of the force of the spring? Well, the force of the spring, 720 newtons. 720 newtons, I put that in. Oh, that is my force of gravity. They're the same. So it's 720 newtons. There you go. Force of the spring, 720 newtons. Force of gravity, negative 720 newtons. Equal and opposite. There's the opposite with a little negative sign. All right, now a lovely, amazing student comes by and sits in Mrs. Needle's chair. Now you have your new K. 3,000 Newton meters, compressed 5 centimeters, which is 0.05 meters. It's an X. And then what else am I looking for? I'm looking for the force of the spring plus the force of gravity, the feeling of weight. It's the mass is the stuff, and the weight is the feeling of heaviness. So looking for these two. Well, force of the spring, Kx, force of the spring, 3,000 Newton meters times 0.05 meters. Notice that the meters cancel out. 3,000 times 0.05. The force of the spring is 150 newtons. They're the same. Here's my free body diagram. Force of gravity would be, mass times gravity, but in this case, it's also equal to the force of the spring, Kx. They're equal and opposite. Force of the spring will equal the force of gravity. Don't have to do all that fancy work. Just go. So they're the same. 1,500 newtons. No, I say 1,500. 150 newtons. And this is negative 150 newtons. There's your answers. All right, now for a little more challenging ones. Mrs. Nagel inflates more into the ball. The charming physics student whose mass is 65. So now we have some more interesting things going on. Da-da-da. Force of gravity, force of the spring of the ball. Let's list my variables. I have mass equal to 65 kilograms. Remember, I weigh like 68 kilograms. All right. I don't weigh. My mass is 68. My weight is the feeling. I would have to multiply it by 10 to get my feeling of 680 newtons. Multiply it by 10 to get the feeling of weight. All right. What else is going on? Her ball chair is compressed 12 centimeters, so it's 0.2 meters. What else do I know? I know gravity is 9.8 meters per second squared. Technically, it's going down, but this is also showing going down, so watch out for the double negative things. What else do I know? Oh, well, what's to know what the weight of the weight? That's the feeling. Feeling of heaviness. Heaviness. All right, and I don't know what K is. K is a question mark, so there we go. Well, hopefully you've seen up here that the force of the spring is equal to the force of gravity. Oh, these are terrible letters looking. That's a G. So this is Kx and this is Mg, or they're equal to each other. You know what? It's kind of like what you're thinking about. Da-da-da. Well, let's do the force of gravity or weight. Well, that's 65 kilograms times negative 9.8 meters per second squared. Watch the double negative. Just make sure you know that that's all that is a directional thing. So 65 times 9.8, 637 newtons. Oh, that means that this stuff is equal to each other. So the force on the spring is also equal to 300, the same. Oh, this is down technically, that's down. And they're same. Because they're equal and opposite, now I could technically solve for K here. So I could say my force of the spring is equal to my force of gravity. I replace that. 637 newtons. That's that. What's this? Use your knowledge. Well, now I could say 637 newtons and solve for K here. So I divide by the, whatever the X is. What's the X? So, what X? X is 0.12. Divide by 0.12. Oh, yeah, and that's a meter. So X's cancel out. Now I'm left with K is equal to 637 newtons. Divide by 0.12 meters. Cannot leave it in fractions. So divide by 0.12. It is a very strong spring constant. And I'm just going to leave it there. Newton meters. Voila. There's your K. Gotta do the same thing for number 8. Charming physics student, 78 kilograms. So I'm going to do my mass, 78 kilograms. Compression, 0.08 meters. That's the 8 centimeters. What else do we know? We know gravity, 9.8 meters per second squared. Technically negative. K, we don't know. We're looking for it. Well, first of all, what's the weight of the student in newtons? Weight is the feeling of heaviness. So that is 78 kilograms times negative 9.8 meters per second squared. So here's my free body diagram. The force of gravity will equal my force of the spring. They'll be the same, so if I find that, I find this. Ta-da. 78 times 9.8. 764.4 newtons, and it's going down. So, negative 64.4 newtons, it's going down. What's this mean? This means it's going up. Positive 6464 newtons. solve for the K. So K x equals 764.4 newtons, because that's the force of the spring. This is the force of gravity. They're both equal. Notice I kind of got rid of the negative sign because I'm trying to show that these two are the same, just equal and opposite. I'm solving for x. So then what is my x? 0.08 meters. 0.08 meters. X's cancel out. K is equal to 764.4 newtons divided by 0.08 meters. K is equal to, drum roll, hey, I'm going to let you finish that one out.